Well, thank you, everybody. Really appreciate everyone coming out. Thank you, Jordan. Thank you for reaching out to us, and Alessio for connecting me with Jordan. We really appreciate it. I'm Jason Gholston. I'm with Magic Leap. At Magic Leap, I am a Senior Director of Ecosystem. What I do there in that role is work with our developer community to get software up onto our device to fulfill various use cases and hopefully help people do their work better, faster, safer. And so we're just going to dive right in here. And so, we work from this premise that there is a lot of data in the world, and that AR computing, spatial computing, is particularly well suited at displaying that data, putting it where it needs to be in a contextually relevant way, and providing means by which to interact with that data. And so we are focused on that at Magic Leap. We want to build devices, software, operating systems, and solutions that enable people to do their work and deal with this data. And so to do that, to make a device that's comfortable, something that someone would want to use as a critical tool as part of their day-to-day job, it's really important that we have solid hardware. And for us, we released Magic Leap 1, a lot of learnings from that, carried those into Magic Leap 2, and with a particular focus on comfort and wearability. I think some of you have already tried the device. We like to think that it is lightweight, easy to put on, doesn't feel that it isolates you. You're able to continue to have conversations with other people around you and see the information you need to see. But critical, before a device can become part of your day-to-day toolkit, in the case of a wearable, it needs to be comfortable. And so in order to achieve that goal of comfort, but not lose performance, we did some things like move the compute and battery off of the head into a compute pack. We focused on visual comfort, so we have 4 eye tracking cameras in the device to constantly align the images to a broad range of different physiologies and vision capabilities. And we also, designed the headset, the form factor of the device, of the wearable part, is able to address a bulk, what is that? God, I think it's something like 95% of the human population. And we do all that with one hardware design. On Magic Leap 1, we had to support 2 different hardware layouts, a big and a standard. And through that design, we also want, like I mentioned earlier, not have you feel isolated from the world around you. And that's where safety and contextual awareness become so important. And that's also, your ability to hear the world around you as well as see the world around you and the people you're interacting with. And so we're focused, and through all these learnings, you were very much focused on the user. And so that first point of the performance wearability trade-off, we want to do really great at AR. An important component of that is world awareness, world reconstruction. And to do that well, you have to have some real hardware, some compute capability at your disposal. But for good compute, you're going to generate some heat, and you're going to need a pretty big battery. So we did offload our compute and battery to a separate pack. And that allowed us to drop the weight on the headset to 260 grams. Now, by comparison, a Quest Pro, a Meta Quest Pro weighs something around 722 grams. So you could almost put 3 of these on your head, and you just get up to around what a Quest Pro weighs. And so that's really important. And then we have, to get that compute and to have the headroom to do the graphics, to have the interactivity and the world reconstruction, we have active cooling on the device. So that allows you to just get more work done that way. And by comparison to our first generation product, we have 2 to 3 times the compute. We have a dedicated computer vision processor. We have more RAM, so we have 16 gigabytes of RAM, 256 gigabytes of onboard storage, and some Bluetooth 5 and Wi-Fi 6 for some good connectivity, which opens up a lot of different use cases. So as part of the visual comfort, which is part of that wearability, if you're having constant eye strain with the device on your head, that's not going to work for you. So visual comfort is paramount. And so we've done a number of things. The device can work in all kinds of lighting conditions. This particular room is quite dark, but we could take and do the demos you've seen today, and those who haven't seen them, come on by, we'll give you a chance. We can take those out in the noonday sun under full sunlight and give those same demos and have all that legibility of the content. And that is thanks strictly to the dynamic dimming technology, which is in our optical stack, in addition to the 2000 nit peak brightness of the projectors. We have 4 eye tracking cameras, which allow the constant adjustment of the picture to adjust IPD automatically and make sure that you're getting the best image quality possible given how the headset is fitting to your head. And we also allow for custom RX inserts or corrective lenses so that it feels like your own bespoke AR headset, and allow people who need a corrective lens to have the same kind of quality of experience that someone who doesn't need a lens would ordinarily enjoy on such a device. Now, in most people's work, they do have to read text, and in AR displays, historically, text legibility has been a real challenge. Even with our first Magic Leap 1, you could read some text, but you had to make it pretty big. With the Magic Leap 2, we can put up web pages with pretty fine text, and you can still read that. And so through a combination of our ability to resolve detail very well and our peak brightness and color uniformity, you can have something like this where we have a Wikipedia page and be able to read it. Now, here is a side-by-side comparison with another very popular AR device, and you can see some of the differences there. Now, one of the key advantages, or one of the most noticeable advancements in this iteration of our hardware, is the increase in the virtual content field of view. So we've nearly doubled the total area of virtual content. So here in the image you can see that total area grow. And so that's the Magic Leap 1, and then it grows, and that's effectively what the Magic Leap 2 is. And it's interesting because most people, they see the portrait orientation of the display and they're like, no, I want it wider. But the thing is, with that portrait display, it does have a lot of biomechanical advantages. So if you think about how the human, physiologically, a human being is very comfortable kind of swiveling their head back and forth, to track things against the horizon. But what does end up causing a lot of strain and fatigue is the tilting of the head up and down. And so we did do this vertical orientation, which allows for things like a menu, like a page of a web page or a document or even a 3D model, or in one use case, a 6-foot-tall avatar. So we can have a 6-foot-tall avatar 6 feet away from you, and it'll fit cleanly within the virtual field of view. And so by not having to tilt your head up and down, that again makes the comfort level of the device much higher, because you're not constantly looking like this up and down, thinking, hey, do I see everything? Have I see the menu? It's very common with the other devices, previous generation, to have like a menu item like the OK button be cut off at the bottom of the screen. That's much less likely to occur. And so for comparison's sake, again, here's another side-by-side, just graphic to illustrate the point of where the Magic Leap 2 sits relative to some other headsets. So the green being a HoloLens 2, and Magic Leap 1 there in the purple. And so this is, it makes a big difference. It's easily and instantly discernible. And so because this is aimed at work and we need to get a lot of people into the headset, we did a lot of human factor studies in order to create a design that worked well for most of the population. And we did that through the scanning of heads and modeling. And you'll notice it's very easy to get on and off, it's comfortable, and it accommodates all kinds of different shapes and all kinds of different hairstyles and hats and things like that. And including hard hats, for that matter. And so that design does reinforce, because of where the temples are, where the frame is at, allows you to have that situational awareness, which is really critical in a work situation where you're out in the field, you're doing your field service, repairing a high-value machine on an assembly line or at a facility somewhere or in an operating room, and you need to know what's going on around you. And we also, again, as a work device, we need to accommodate different kinds of input capabilities and modes. We support voice input, virtual and physical keyboard, physical key layouts. We have a controller, we can do hand tracking, and we have a gaze and gesture input as well as head tracking, which you can use for some very interesting input modes. Now, here's a sort of a layout of some of the devices that address or are comparable in one way or another to the types of use cases and solution or problems we work to address. So you have a RealWear, you have a Vario being a very high-end, very expensive headset. Quest Pro with mixed reality video pass-through. HoloLens 2, which is more in the vein of our device, which is an optical see-through augmented reality computer, and then of course the Magic Leap 2. And there's a few really interesting specs to call out here. The weight for one, wearing something that's almost a pound on your head all day long or a half pound, makes a real difference. We have surgeons who are doing procedures and wearing our headset for 8.5, 9 hours straight. And so the difference of 260 grams as opposed to 722 grams or even 566 grams is the difference between the literal pain in the neck and some real pain, discomfort. Our runtime somewhere around 3.5 hours. And our displays are addressable resolution of 1440 by 1760 per eye. So you can resolve a very sharp picture and a lot of detailed data. And so all this hardware is for naught if there's not actual software to run on it. And so one of the lessons learned from Magic Leap 1 was to make things easier for developers, adopt open standards, and try to hewn to or adhere to kind of standard development practices whenever we can. Obviously, there's sometimes we have to forge our own path to accommodate our particular hardware and some of the things that are capabilities that our device has that other platforms may not. But for the most part, we're trying to stick to open standards. And so you can see here, hey, you want to write your own render in Vulkan, go for it. You want to use Unity and build using Unity, build a solution inside that environment, please have at it. Maybe you want to do WebRTC, or do WebXR and do a WebXR-based experience. These are all options available to you. So one thing, if you happen to have a VR app that you think could move over to Magic Leap 2 well, you have the option of using Unity and MRTK, for instance, or leverage Vuforia engine, which runs on Magic Leap 2. We also are partners with Agora and VisionLib, which allows some middleware that makes building connected apps or apps that need to do object tracking, object detection, and those kinds of things much easier. And importantly, we are OpenXR compliant, and that opens up some interesting options down the line for us. And we'll have many more announcements soon in regard to our developer options and our developer ecosystem. We're really, in many respects, just beginning this work. And so let's say you wanted to go we come to our developer portal, developer.magicleap.com or ml2-developer.magicleap.com, and you can download all of our developer tools for free. You can download the Unity SDK, our app simulator, which is there, our step-by-step guides, get access to our developer forum and our debugging tools and performance optimization tools. Just download them. And to download the tools, you don't even need to create an account. We'd love it if you did, but you don't have to. And so we try to give you some nice handholds, ways to begin your work. And so visiting our knowledge base, you can see featured guides on how to set up your development environments and such. And so one thing I thought would be interesting to talk about with this group is enterprise AR is a growing segment, and with a lot of opportunities that game developers and people from the games industry are particularly well suited or uniquely qualified for. And so that's one of the things I thought would be fun to talk about. So for instance, many game developers have a lot of 3D experience. They understand 3D pipelines, they understand 3D math, they understand how to deal with data in a spatial way. Their games, for them to make money, for the games to succeed, they need to be able to bring the player on board into their world, into the experiences they're crafting, and train them up on all the mechanics and all the interactions and all the data you're putting at them so that they can make informed decisions in the game. These are critical skills for building AR solutions. It's the same thing, so that's a very valuable background there. To have a commercially successful game, you have great UX and aesthetic sensibilities. You're communicating effectively and clearly through graphic means, through auditory means, through all the sensory modes. And that also useful in our context, because we're talking about experiences and tools that can take place around you. You need to be able to get someone's attention over here. You use a sound cue, you use a graphic, perhaps even use some of the tropes and common patterns and practices you might see in a first-person shooter, for instance, to help someone do a better job in a guided work instruction kind of scenario, or a training, or a wayfinding app, or a guided tour app through a facility. So that sensibility, that understanding of UX, how to make something complex easy to understand, is a critical skill that being in the market of games, building commercially viable games, sets you up to understand these concepts very, very well. Likewise with performance optimization. You want to build the best, compelling, most interesting experience possible for your game. You want to wring out every last little bit of performance on your hardware. That is a useful skill to have when you come to AR. It's the same kinds of instincts, the same kinds of challenges. And there's folks who come from very other areas of software development that didn't have to work necessarily against those same kind of constraints and performance demands. And AR applications really do thrive when you keep an eye on that kind of thing and you understand what the trade-offs are and how to make those choices between the complexity of the content you might be showing, or controlling the input, or hiding some latency in this or that. These are all useful skills that do get exercise building games. And ultimately, games are complex. Games are hard, and being able to deal and have comfort with and the ability to thrive dealing with that kind of complexity, not letting it throw you off, and to be able to just roll with that and experiment and learn, does allow for innovative AR enterprise applications to get built. So for any game developers who are looking to kind of try something else for a little while, this whole enterprise AR thing might be the thing you're looking for. And so with that, I say thank you, and if you have any questions, yeah, sure.